Let's go over some examples of how to translate between scientific notation and standard notation. All right, so for example 1, we're going to be completing the table. In the left-hand column, we have some numbers that are written into scientific notation that we need to translate into standard notation. Scientific notation translated into standard notation. We also have a couple numbers that are in standard notation that we need to translate into scientific notation. So let's just get started with the first one. First, we have 3 times 10 to the 8th power. Right away, you should notice that you will be making a large number. You know this because your exponent is positive. The decimal is sitting after the 3, and to make a large number, we will be moving the decimal to the right. If you move the decimal to the left, you're creating a small number. So that kind of helps you know which direction you're going to be heading. Don't think of it as positive goes to the right or negative goes to the left, because that starts to get confusing as you translate back and forth between these two forms. It's better just to remember positive exponent, large number. So let's go ahead and move that decimal 8 times. Basically, we're just adding 8 zeros because that decimal is not jumping over any other number. And so in this case, it does happen to represent the number of zeros that we'll be adding. That's not always the case. So in standard notation, we have a 3 followed by 8 zeros, which puts us at 300 million. Okay, so now let's look at this number. We need to write it in scientific notation. Currently, it's in standard notation. So we know the decimal's sitting right here. We need to move it so that it is sitting with one digit to the left of it. So it's going to be right here. So we are moving it 1, 2, 3, 4, 5 places. So we have 1.09 times 10. And we know it's going to be a positive 5 because the number in standard notation is a large number. 2.1 times 10 to the negative 6, we're going to translate that into standard notation. This is telling us we are making a small number. The decimal's sitting here. We're going to move it 6 times. We are not going to move it to the right 6 times. If we move it to the right 6 times, we're creating a large number. We need to move it to the left 6 times. So I'm going to give myself some room to work, knowing that I'm going left with my decimal. And I'm going to move it 1, 2, 3, 4, 5, 6 places. Each of these empty spaces gets filled with a 0. So basically I have a decimal followed by 5 zeros and then 2, 1. And a lot of times we put a leading 0 out front just to show that decimal nice and clear. So we have 5 zeros followed by 2, 1. So there's only one decimal in our answer. Oftentimes I'll see students leave both decimals there. That's not representing anything I'm familiar with in math. We don't have 2 decimals in a number that I've ever worked with. So just make sure that when you're finished, you actually completely finish the problem and make it very clear what your number is. Okay, last one, standard notation. We're going to write it in scientific notation. We have a small number. We're going to have a negative exponent. The decimal is sitting right here. We need to move it right here because we need one digit in front of the decimal or to the left of the decimal that is not a 0. So let's count how many spaces we have to move it. And again, you can count by 3s like I did in the last video. You can count each one. It's up to you. I'm going to go ahead and count this one by 3s. So there's 3, 6, 7, 8 times that I have to move my decimal. So what we have is 7.1 times 10. And since this is a small number, we need to remember that our exponent is negative. All right, moving on to example 2. Now we're going to be finding the value of n. And for part A, you can see we have a number in standard notation. And we have a number that is starting to look like scientific notation, except we need to find out what our exponent is. And in this case, it has to be a positive number. We know n has to be positive because our number in standard form is not a small number, it's a large number. Large numbers, positive exponents. So we just need to figure out how many places the decimal has moved to end up right here. If you forget where the decimal is when you don't see one, try to remember it's just at the end. We just don't write it. So we are moving it from here to right here. And so you just count how many spaces you've moved it. And you can count them individually. You can count by groups of 3. I'm going to go with groups of 3. So there's 3, 6, one more makes 7. So we have to move the decimal 7 spaces for this particular number to be put into scientific notation, which means n equals 7. All right, part B. Now we have 404 billion being written in scientific notation. Again, a large number, positive exponent. Notice that this 0 didn't disappear. This 0 is still represented here. The zeros that you drop are once you have only zeros remaining. You can't just take out that 0 thinking, oh, we don't write zeros. Definitely okay to write zeros, especially in this case, you need to write the 0. All right, so how many places did we move the decimal? Well, it lands right here. It started back here. So 3, 6, 9, 10, 11 places. It's a positive 11 because in standard notation, we have a large number. So 4.04 times 10 to the 11th power. All right, part C. Now we have a small number, which means our exponent is going to be negative. You could even help yourself out by writing down n equals negative something, so you don't forget to write that it's negative. The other thing that I want to make sure I point out is this 1 does need to be there to be in scientific notation, even though it doesn't change the value of this expression. To be in scientific notation, you do need a digit being multiplied with a power of 10, and not just a digit, but a number where you only have one digit to the left of the decimal. So we do need that 1. All right, so how many places did we move the decimal? Well, it landed right here. Don't forget it's sitting there if you don't see it. So if it landed here, that means that we are going to move it to right there, so that we have one digit to the left of the decimal that is not a 0. So we are moving it 1, 2, 3, 4 places. Don't just count the zeros and think, oh, it's a negative 3. You do need to remember you have to move it past that digit as well, that number that is not 0. So this would be 1 times 10 to the negative, because it's a small number, 4. We moved it 4 spaces. Our original number is a small number. All right, last one for example 2. Again, very small number. Our exponent is going to be negative. You could write that down right away so you don't forget that negative. Notice that the 0 is still here. They did not drop that 0. It is needed to hold that place value. If you drop that 0, you change the value of the number. This 0 is needed in your scientific notation to represent this number. We just need to figure out how many places we're moving the decimal to get it to land right behind the 2 so that we have one digit to the left of the decimal that is not a 0. Lots of zeros here. I find it more helpful to count by 3s than by 1s, but that's up to you. So there's a group of 3. There's 3 more to make 6. 3 more gives us 9. So this becomes 2.03 times 10 to the negative, because it's a small number, 9. All right, last example does have a few parts to it though. Directions say write each number in scientific notation. So for part A, we have 24.5 times 10 to the fourth power. And if you don't look carefully, you might think, well, it's already in scientific notation. I don't have to do anything. But look a little closer. Notice that the decimal is sitting right here, and there are 2 digits to the left of it, which is not scientific notation. Scientific notation means you only have 1 digit to the left of the decimal, which means we need to move this decimal 1 extra spot. So then the question becomes, how is our exponent going to change? We know it's going to change by 1 because we're moving it 1 more spot or 1 less spot. So it's either going to become a 3 or a 5. So to know for sure, it's usually helpful just to write it out. So we start with 24.5 times 10 to the fourth power, which means we're creating a larger number since it's a positive exponent, and we're moving the decimal 4 places. If we move the decimal 4 places to make a larger number, we're going this way 4 places. So 1, 2, 3, 4. And we would fill in these spots with zeros. So our standard notation number for this particular one would be 245,000. Then if we take that number and put it into scientific notation properly, so that there's only 1 digit to the left of the decimal, we're moving it 4 places and 1 more. So then it becomes 2.45 times 10 to the positive 5th power. That is scientific notation. These are equivalent. This one is not in scientific notation. This one is. They both represent 245,000. All right, part B, 0.032 times 10 to the negative 7. Notice that I used a dot instead of an X for multiplication. Oftentimes you'll see it with the X, but every once in a while I've seen it with the dot, so you just need to be ready for either one. We have 1 digit to the left of our decimal, but it's a 0, which is not okay if you're writing a number in scientific notation. Even though this looks like scientific notation, this is not scientific notation because of that right there. So we need to move the decimal until there is a digit to the left of it that is not a 0. We're going to move it right there. So we're moving it 2 places. If we're moving it 2 places, that's going to change this exponent by 2. It's either going to move down to negative 5 or up to negative 9. We have to figure that out. Easiest way to do that, instead of trying to remember 1 goes left, 1 goes right, and all that kind of stuff, just write the number out following these directions that they give you right here. So the directions say that we have 0.032 or 0.032. We're moving the decimal 7 places to make a small number. We know it's a small number that we're making because of the negative exponent. If we moved it 7 places this way, we'd be making a big number. So we need to move it 7 places this way. All of those empty spots get filled in with zeros. And then we have to move it all back and 2 more, which means that it's going to move a total of 9 spaces to be in scientific notation. So follow the directions they give you. Decimal starts here. We're moving it 7 spaces to make a small number. So we do that. To put this number into scientific notation, we have to move it back all the way where it was and 2 more spaces. So we are moving it 9 spaces. So to put this number into scientific notation, we would have 3.2 times 10 to the negative 9. All right, so numbers in scientific notation have 1 digit to the left of the decimal that is not a 0. This one was a 0, that's why it wasn't scientific notation. This one had 2 digits to the left of the decimal. That's why it wasn't scientific notation. To translate it, you just have to move the decimal, but if you move the decimal, you must also change the exponent to represent how many spaces that decimal has to move to get your number into standard notation. So write it out following the directions they give you. Then translate your decimal wherever you need it to go to put it into scientific notation, and track how many spaces you moved it, and also whether it's a large number when it's in standard form or a small number when it's in standard form. Large number, positive exponent. Small number, negative exponent. Hopefully that helps and you're getting some confidence in writing numbers in scientific notation and standard notation, and vice versa.